not exploding, and we are almost done. So big applause for Tanner.
Hello, so my name is Tanner, and this presentation is going to go over one of the three bounties, our biggest bounty, which is cross-chain swaps. There are two other bounties. One is limit order protocol, and one is our SDKs. Those will not be covered in this just because I only have 20 minutes, but I will link to presentations that go over both of those bounties from previous hackathons that you guys can check out as well after this. So let's jump in and talk about cross-chain swaps, also known as Fusion Plus by me. I don't know if I mentioned it, but I'm a developer relations engineer at 1Inch. So in the presentation today, we're going to talk about our classic swap, which is what we originally came out with back in the day, 2019 or 2020, and that is AMM and PMM aggregation on-chain. We will then talk about 1Inch Fusion, which was our implementation of intent-based swaps. And then we will go on to 1Inch Fusion Plus, which is our cross-chain swap, which is our latest swapping platform that we released in the past couple years. And then we're going to talk about how you guys can actually build projects for the cross-chain swap bounty at the end. So let's jump into swapping with 1Inch. So here are all the chains that we support today. We have Ethereum, some alt L1s, side chains, and then a lot of the major L2s. And additionally, we support our intent-based swapping and our cross-chain swapping on Solana, which is kind of this new frontier we're doing to reach out beyond the EVM. So let's jump into what Classic Swap is. So if you're a user on Classic Swap, you are going to be getting all of your liquidity from all popular protocols in one place. Our algorithm will combine all of these protocols together to optimize swap output for the user. And then all of these swaps that happen across the chains in your transaction on one chain will be in a single transaction. And let's just take a simple example like USDC to DAI. So if a user wants to swap USDC for DAI and they're like brand new to the ecosystem, they'll probably just go to Uniswap. That's what everybody knows. It's got the deepest liquidity, low price impact. But let's just say they're a slightly more sophisticated user, or maybe they have some friends who are already pretty deep in DeFi. They might go to the 1Inch router first. That's where our classic swap will go through and check all liquidity sources and probably still end up sending you to Uniswap. But again, that's because they have really deep liquidity, really good price impact, and that's just where a lot of swaps happen no matter how you look at it. But if they do like a large swap, like let's say 1,000 USDC, 5,000 USDC, or even more, then you start to really see some cool benefits on these major trading pairs. Part of your trade might be split across Dodo. Part of it might go through Curve and be swapped to USDT first, and then go through SushiSwap from USDT to DAI, and it'll just keep getting more and more complex to get you the best possible rate on that swap. Some of you might be thinking, oh, but that also increases the gas costs, and that's true, and we factor that in as well. So if a simpler swap gets you the net most output, factoring in gas costs, then we'll do that too. So now let's just look at like, if the base case is going from 1Inch router just to Uniswap anyways, like shouldn't I just be using Uniswap? Well, we can compare the gas usage on that too. So if you just go to Uniswap's front end and you do a swap through their main router contract, you use about 205,000 gas. And if you go through the 1Inch router, which forwards you to Uniswap v3 liquidity, you'll actually only use 175,000 gas. So even in cases where you go through these major trading pairs, you'll still save money going through 1Inch. So in the end, this is what we kind of imagine is all swaps will be going through these aggregators, because it just kind of makes the optimal output in the end, kind of no matter how you slice it. The reason for this is because we skip the router entirely. We write our own custom code that just talks to the liquidity directly, and so we can just beat them over time by optimization because they're immutable contracts, and we will update our contracts slowly over time. Like our router right now is on V6 across 5 or 6 years, so eventually I'm sure that we'll have a V7 as well. So let's move on to Fusion Plus now. So this is the intent-based swaps, which kind of flips the whole traditional swapping on its head. A user now, instead of submitting a transaction on chain, will submit a swap request with a signature. A Dutch auction will be created for the swap that the user wants to do, and resolvers will asynchronously compete to fill it. And in this system, users are protected from MEV by design, which if you're not familiar with MEV is just ways that third parties kind of steal value out of your trades without you ever knowing about it. And additionally, this is also gasless for the users. So they don't need the native token. They don't need ETH on Base. They don't need BNB on Binance Smart Chain. They don't need, it kind of simplifies the UX and the complexity of swaps for users. So I threw a lot of terms at you there. One of them was a Dutch auction or a fusion Dutch auction. We can kind of talk about Dutch auctions more broadly, which is where instead of you having an auction that starts at a low price point and slowly goes up to a higher price point until there are no more bidders left, a Dutch auction just flips it on its head where it starts at some high price and then it goes down to a low enough price to where one bidder says, hey, I would actually like to buy that. In this case, I'd like to swap those tokens at the given rate. That's slowly moving down. Another term I mentioned was what is a resolver, and these are just the counterparties in the Fusion system. So in Fusion mode, in our intent swap, there's some number of counterparties that are watching these Dutch auctions over time, and they are the ones that actually fill the swaps on behalf of the user once the price reaches a certain point. So let's just look at a very simplified graph of what happens behind the scenes in the Fusion system. On the y-axis, you'll have the rate for the token swap. On the x-axis, you'll have time. And it starts at some maximum value, either market rate or slightly above market rate. And over time, it will slowly go down to some minimum, at which some point along this curve, a resolver will jump in because it's an advantageous trade for them, and they can make money on that swap. So we'll go through an actual diagram so you can get a better idea of what's going on here. The user says, I would like to swap 50 USDC for DAI in the Fusion system. That'll estimate that they'll get somewhere around 50 DAI back because they're stablecoin pairs. They will sign this transaction, and they will send this off to the 1inch API. The 1inch API will then trigger the Dutch auction that is going to start, and it will start feeding this information of the Dutch auction to all the resolvers in the system. Now, at the beginning, since it's basically market rate or slightly above market rate, everyone will pass. You know, this is block by block. It's slowly going cheaper and cheaper. But eventually, resolvers will say, hey, this is actually something I'd like to fill for the user. In the case where multiple resolvers are competing at the same time in the same block, whoever pays the most gas will win. But if they do partial fills, which is totally valid on our system, there might be a case where they both are able to jump in and do that fill for the user. So until the full 50 USDC is swapped, this will just kind of keep going down to some minimum auction at which it'll expire if nobody has done it, but usually it gets filled long before that. Here's a much more complicated graph of a real swap that happened inside of the Fusion system for 3,700 Ether, which is very, very large. The slanted line with the dots on it is all points at which resolvers jumped in and did a partial fill. It's a little small, so I'll just describe it. Don't worry about seeing exactly what's going on. But the dotted line, horizontal dotted line underneath all these dots is market rate. So at about 4 minutes and 48 seconds, there were 17 partial fills that filled the entire swap for all 3,700 Ether, all slightly above market rate. So this is stuff that you just can't do with traditional AMMs, with traditional DEXs. It's kind of like the next evolution of token swaps on chain, and this kind of proves it, because this is a real swap that happened inside of our system. So another question you might be asking is, where do these resolvers actually get the liquidity? They can get that basically from anywhere. We don't really prescribe how they need to make these swaps happen. We just give them the exact on-chain rates that need to be enforced. So they might get it from a centralized exchange that they're doing arbitrage on. Maybe they're a family office and they just do really, really large trading pairs. Maybe they have found cool opportunities within the DEX ecosystem, doing arbitrage between DEXs, or maybe they find arbitrage opportunities across different chains. However creative they can get, as long as they are satisfying the on-chain requirements, that transaction will post, and they will do either part or all of the swap on behalf of the user. Okay, so let's jump into Fusion Plus, which is our cross-chain swapping. So when we started kind of diving into cross-chain swaps, we asked ourselves, what are really important to users? Well, first is good swap rates, because users actually are going to go eventually to wherever they can get the best rates for their trades. Simple UX, because if you have new users that are coming into the system, it can't be too complicated or they won't use it. And the last one is trustlessness. And maybe they don't care about that now, but they definitely will care about it if things start to fail. So we wanted to make a system that was as trustless as possible, which is kind of the hardest part of building a bridge in general. And we came on to hashed time lock contracts. So hashed time lock contracts are just smart contracts that hold funds, and they require some secret S to unlock those funds. And if that secret S is not provided within a certain amount of time, the contract is set to expire, and the only thing that can happen is the funds go exactly back to where they came from. So if we have some user, they have some secret S, and they want to create this hash time lock contract. So they make a hash of S, and they send that into the creation of this contract, and they also put some sort of funds on this contract. And if someone else comes to this contract and they can see those funds in there and they try to remove those funds or withdraw those funds from the contract, it will be completely impossible unless they can provide that original secret that the user has. So up until this secret is shared, these contract cannot be accessed in any way besides from the creator because they have S. Once they share S, then other people can actually interact with that contract and unlock those funds. That is kind of the very high level summary of kind of what the technology provides with hashed time lock contracts. So let's go through another diagram. The user says, hey, I have 50 USDC on Ethereum, and I would like to swap that for 50 DAI on Base. They sign the transaction just like in the Fusion system, and they send that off to the 1inch API. The 1inch API, again, starts a Dutch auction, but this time between two different chains. And just like before, all these resolvers are looking at this over time, and as the blocks progress, the price goes down, and eventually they jump in and they say, hey, I'm interested in executing this trade. Partial fills do work in the system, but for now we're just going to go through the examples of full fills from a single resolver. And once they claim this swap, then they jump into the unique logic that happens in the Fusion Plus system. So they will create an escrow contract on the source chain, in this case Ethereum, and they will provide a safety deposit now. And this is just some sort of financial incentive to make sure the funds don't get stuck there indefinitely. When they complete this swap, once it's finished, they get that safety deposit back. And this is, again, a financial incentive to not let things hang and get stale. They will also create the escrow contract on Base as well, in the destination chain, which in this example is Base. And once they have these two escrow contracts in place, they will use the permission that the user had originally granted to the 1inch router to transfer that USDC from their wallet into the escrow contract on the source chain. And then the resolver will provide the DAI to the escrow contract on the destination chain. So now we have two contracts, two chains with all the funds from both sides of the swap that will make both parties happy. And now jumps in the relayer service. This is a service run by 1inch currently, but eventually will probably be fully decentralized once we get to that point. This is kind of a monitor of the state of these two chains. So it's watching the escrow chain on the source, escrow contract on the source chain, it's watching the escrow contract on the destination chain, and it's saying, hey, did the funds actually get there? Once the funds actually get there, they'll wait for some finality period. I'm assuming on Ethereum it's like 2 to 3 blocks, so something like 36 seconds or so. And then it'll say, okay, everything's good, finality on both chains has been reached, we have the funds on both chains. It will then reach back out to the user and it'll say, hey, now it's time for you to share the secret. The funds look good, everything looks good. Now let's actually get those funds unlocked. So the user shares the secret with the relayer, and the relayer then passes that secret on to the resolver. This is the original counterparty who started this whole cross-chain swap for the user. It will also share this secret with all of the other resolvers. And the reason for this is if resolver 2 for some reason does not actually unlock the funds and complete the trade, other resolvers can jump in and do that on behalf of resolver 2, and then they get that original safety deposit that resolver 2 actually deposited at the very beginning. This design is actually not limited to just EVMs, as I guess you saw earlier, because we're on Solana. It just needs to be a chain that can support hash time lock contracts. That's Bitcoin, that's Solana, that's really most chains. They have some form of support for hash time lock contracts because a lot of them have smart contract languages. So now let's actually talk about how to integrate this product into a non-EVM chain. As you guys, as the hackers, if you're choosing to go down this bounty, your primary goal is to manage the hash time lock contract implementation and communication between your chain and an EVM chain. That means properly handling the hash lock contract, properly handling the expiration and reverts of this contract if it expires, and the swaps between the two chains must be bidirectional. So you can either start on the EVM chain or you can start on whatever chain you choose to integrate. What this actually looks like from an integration side is you will have your side of, your implementation will talk to the 1inch router, which has the limit order protocol inside of it, which will talk to the 1inch escrow factory, which will actually deploy the 1inch escrow contracts. And then the part that you're building that's custom is going to be whatever non-EVM chain you're choosing, and then managing that secret sharing and secret management that we went over in the examples earlier in the presentation. So you need to actually integrate with our live contracts to kind of prove that this isn't just a hash time lock contract implementation, but one that'll actually interface with our system. For the demo, the on-chain transactions should be shown on a block explorer to actually prove that they worked. We have base airdrops where we can just give you some 1-inch tokens, and you can use our system to swap that for Ether or whatever else you want to do to prove your demo works. Just come talk to us. We can give those to you. You can do all of this on the CLI. You don't need a UI, but that'll be bonus points. But doing this on CLI is enough because this is a pretty challenging bounty. And an important note to make is that once you start going through our documentation, you'll see that creating orders on the cross-chain system usually involves a REST API. This is not how you'll be doing it because the resolvers in our system are whitelisted and not anybody can just join. So you'll actually be doing this purely from this, like your JavaScript plus interacting with the smart contracts directly. Okay, so where do you actually start? That was a lot of information. There's actually an example repo that does all of this with a test net, or with local forks of 2 mainnets, so that you can see an entire working example if you want to go down this path. Don't worry about taking that link. We'll have more copies of it later at the end of the presentation. This example is going to be in TypeScript. It's going to simulate a Fusion Plus swap between Ethereum and BNB. And it has all of the information you need that was earlier in this presentation so that you can actually build your own version. This is what the README looks like. You just need to have PNPM installed and Forge, and then just follow that in a couple steps, and you'll see the whole test running. So here is the bounties. So the one that we just went over in the presentation today is $6,000 for the top 3 implementations. The next one is extending our limit order protocol. Again, we didn't talk about this, but in the docs I will link at the end. You'll be able to get all the information you want about that. And then just utilizing the 1-inch APIs in general. Top 3 projects will get $250 each. And that is it. So here is a QR code and a link above to hackathon.1inch.community where you can see the slides from this presentation, previous hackathon presentations that go over the other 2 bounties, as well as all the documentation you need for examples, getting access to our APIs, and anything else. So yeah, thanks guys.
You